Okay, in this video, what I'm going to do is I am going to go through the carbon dioxide cycle. You have this exact picture in this lab. So if you want to, and I did include a video, but he kind of goes off on tangents on that video. So if you want to get this lab printed off, and then you can follow with me through this cycles, this carbon dioxide cycle. Now, I'm not a great drawer, you'll figure that out, but I'll try to explain what I'm drawing to the best of my ability. So carbon dioxide is naturally produced. So this is representing a volcano. So we'll put a little V right there. And if you look above this in the lab, you'll see that it says to add a car, all right, to the drawing. So I'm going to add a little car, and don't laugh at my car. Okay, so this is my car. Those are the wheels. Here are little people. All right, and it has an exhaust system, and that's what we're most concerned about. So that's a car. Use your imagination. And I also asked you to draw an island in our ocean. And here's our little island with a power plant on it. And this is a power plant that is powered by the use of coal. So it's going to look not like a power plant because I just can't do that. So here we have our power plant with okay, our little smoke thing coming out. All right, so that's a power plant. Just go with it with me on this. Okay, so what I'm going to do, I'm going to change colors here, and we're going to talk about the natural cycle of carbon. Try to keep it pretty simple. Like I said, this is a volcano, and this would be what's called a subduction zone. So I'm going to give you a little earthquake or earth science lesson here. So what happens, and this actually exists for us in Washington and Oregon. What happens is the lower level here subducts, or it goes down towards the center of the earth, even though it doesn't get close to that. And then what happens is that's what causes earthquakes. One of the causes is when that moves, when it slides down. And then what happens is we get the production here, and then volcanoes erupt. And what volcanoes erupt is when that happens, they put out a lot of CO2. Okay, so this is carbon dioxide, and the blue I'm using is natural carbon dioxide. Okay, or not natural carbon, yeah, natural carbon dioxide. So natural carbon dioxide produced by natural things is that CO2 is going to go into the atmosphere. Now this version of the carbon, there are different versions of different elements. It's versions of carbon that are radioactive and those that are not. Now when I use that term radioactive, in this case I'm not talking like dangerous, like you can't get near carbon because it'll make you get cancer stuff. I don't mean that, but there are different versions, radioisotopes. So some have some radioactivity and some don't. And actually in us, we're a carbon-based life form. We do actually have some small level of radioactivity just because we are made of carbon, okay? Just because we are made of carbon. Now what this carbon dioxide does, what any type of carbon dioxide does, is it's going to go into the atmosphere, and by being in the atmosphere, it's going to act like a greenhouse gas. Now again, there are natural amounts of CO2. This is the sun. I bet you even knew that one. There are natural carbon dioxide. There's always going to be some in the atmosphere. What's going to happen is when the sun does its sun thing, okay, it generates heat, and that heat comes down through the atmosphere. Okay. Now, if all the heat that came through the atmosphere stayed there, it'd be really, really hot. So what happens to a lot of it, it kind of bounces off, okay, and goes back into space, okay, into space. What CO2 does, or any other greenhouse gas, is it keeps more of that heat in. So what'll happen is the heat comes up and it bounces and the heat stays in. Okay, this heat stays in the atmosphere, and then what happens is temperatures go up. Now one thing oceans do, oceans actually do absorb some of that. They do absorb some of that heat, as does ice. So large glaciers and so on, they absorb some of that heat. So when CO2 levels go up, more heat is going to stay in. Now there have been times in Earth's history when the CO2 levels are higher. A single volcano erupting, unless it's a big one, is not necessarily going to increase the CO2 level to such a high level that it will cause a major climate change. Now, you may have heard when the dinosaurs went extinct that the main cause of their extinction was a big old meteorite hit and blew everything up and changed the atmosphere and so on. There's some evidence that even before that, that dinosaurs were starting to go extinct because there was such a high level of volcano eruptions throughout around Earth that it was changing the atmosphere because of this CO2, okay, because of this CO2. So this CO2, the CO2 that makes us up, the carbon that makes us up, and the carbon that's here, again, has some radioactivity in it. It's a radioisotope. Now, what happens, let's go back to CO2 color, is, and this is natural circulation of CO2, that CO2 will come down in the rain, okay, and it's slightly acidic. And what that will do is that slight acidity in that rain will actually dissolve the rock into the ocean, okay, into the ocean, then it goes down, then we have the circle of life, Hakuna Matata, Lion King, the whole thing, okay? So we have a natural circulation of carbon dioxide. And like I said earlier, the levels have changed over time. And again, we can tell that by looking at gas bubbles in glaciers. We can go really deep in, and you got hundreds and thousands of years back, and you can see what the atmosphere, what the air was made of at that time. Okay. All right, so what is happening with other CO2 levels? So here's our little car, okay, here's our little car, and here's our little power plant. Now what these use, your car with gasoline and oil and power plants with coal, is we are using fossil fuels, okay? And what the fossil fuels mean is that these fuels were produced by fossils of ancient, ancient Earth. And so what happens is they came from living things. Obviously now they're dead, but they came from living things. So just like us, they have carbon. But because they are millions and millions of years old, they don't contain any of that radioactive carbon, that radioisotope. They don't have that because over the millions and millions of years where they became fossils, they lost that radioactivity. So what happens is, and what's happening now, is this car, which represents all the cars, is putting out this CO2, okay, there we go, and this power plant is putting out the CO2, and it's not the same CO2. Scientists can distinguish between this non-radioactive type and the natural carbon that has some radioactivity in it. But what starts to happen then, back to our sun, okay, is as the CO2 levels go up, more of that heat from the sun stays here, stays in the atmosphere. So you hear the term global warming. So as CO2 levels go up, temperature goes up. Okay. Now the term climate change is more accurate because not in all places will it get warmer. Not in all places will rain levels go down. Rain levels may actually go up in certain areas because of this. Okay. So this is, if you just look at this by yourself, you'd probably think a 3-year-old drew it. But this is the circulation, the carbon cycle, simplified. This also is going to represent what happens when we use fossil fuels, and then you get an idea of how CO2 levels can affect temperature. Okay, how CO2 levels can affect temperatures. The last thing I want to just show you real quickly, and I'll make up another color, is what excess CO2 can actually do in the ocean. Okay, what it does is excess CO2, first of all, you've got coral reefs, which some of you may pick to do your biome over. What happens is when there's more CO2 and there's more CO2 coming down here, what happens to the oceans is they become slightly acidic. Slightly acidic. Their pH goes down. And what that does is it changes the living organisms, the phytoplankton, all the little things that live within the ocean. Now the coral reefs, what happens to them is what they call it bleaching, is actually it gets so acidic enough that they will start to die. Okay, they will start to die. So it has a dramatic effect on the oceans. The oceans actually can suck in a lot of carbon dioxide, as do trees and so on. But again, it can cause negative effects on the health of the ocean. Okay, so you might have to watch this again. And again, don't show your parents or anybody that I drew this because they won't believe that I actually am a teacher. So this is just, again, you want to go through it again. It's always here for you to look at. It should help you answer the questions that you're going to need to. All right, and if you have any other questions, just let me know.